want to introduce you to Rapidmask, the newest in the family of sand carving photoresist films from Photoabrasive, based on an original concept of DuPont. And Vince is going to walk us through this process. Hi, Vince.
How are you doing, Tom?
I'm good. Now, from what I've read, this is a really easy three-step process.
Absolutely, very easy.
And what are those steps?
Well, basically, it's 3 steps. We expose the film, we apply it to the glass, and then we blast it. And then we're finished.
Expose, apply, blast. Even I can remember that.
It's simple.
Okay. Is there a washout process with Rapidmask?
No, it's a non-washout film. It has the adhesive is already built into the film, so
Great.
we don't have to worry about adding adhesive to the product.
So what do you need to make Rapidmask happen?
We don't need much, Tom. You don't need any of the developing equipment or the drying equipment. All we need to start with is a computer-generated piece of artwork.
Okay.
You need an exposure unit like this electrolyte here.
All right.
Or a flatbed unit like you see back here.
Okay.
But any UV light exposure unit will work. And then the third and most important thing is you need a sand carver and the abrasive that goes into the sand carver.
Right. So all you're saying we need is the computer-generated art,
Correct.
the exposure unit, and the sand carver.
Right.
All right. So where do we go from here?
Well, how about if I tell you a little bit about the films themselves, okay?
Right.
We have 2 versions of Rapidmask. One is called Rapidmask High Tech.
Okay,
All right?
High
And that's a
Tech.
4 mil product. And it's used for conventional etching, things that people tend to do in the way of trophies or awards and things like that.
I see.
And here's an example of something like that you can see there's some depth here in the writing, but there's no real fine detail on here. Okay, so that's where you'd use the 4 mil Rapidmask High Tech film.
Okay, so the normal line art is going to use the high tech.
That's correct.
All right,
That's
and what's
correct.
the other type?
Okay, the other type of film we have is a Rapidmask High Detail.
All right.
And we call it High Detail because it allows you to resolve very, very fine detail work, which is something unique to this concept. And for example, here was a painting that was taken and actually etched onto a piece of glass or film.
So you can do a photograph.
Yes, you can.
High detail.
Yes, you can.
All right.
Up to 65 dots per inch.
Okay. Wow,
Yeah.
that's pretty amazing.
Yeah.
All
Yeah.
right. Well, where would we start from the very beginning to make this process happen? I'm guessing it's going to be artwork.
Absolutely, absolutely. The most important part of the process, in fact. And with Rapidmask, because of the way the film is processed, we actually use what's called a photo negative instead of a photo positive.
Now that looks just the opposite of what I used before.
Right, this is what you used to use before.
Okay.
And the reason it's different is because over here, the areas that were black were the areas that got etched.
Aha.
All right. In the case of Rapidmask, the areas that are clear are the areas that are going to etch.
I see. And this looks very dense.
And it's very important when using a photo negative that the dark, dense areas be very dense, because one thing you have to remember is where the light goes through, this artwork is what you're going to etch. So if there's a pinhole anywhere in that dark area, you're going to etch it.
Okay.
You don't want that to happen.
Right.
So what we've done is we've actually created a family of products called our AccuArt films. And what these films are, they're designed to use in inkjet printers, not laser printers.
Aha.
Inkjet printers.
Inkjet, okay.
And that will actually go right into your paper tray and print out this quality of artwork right from the computers.
And this is reusable.
This is absolutely reusable. You use it over and over again. This is like your working tool that you make, but you have to start with this. And as I tell most customers, it doesn't get any better than the artwork. You've got to have good artwork.
Okay.
If there's a mistake here, you're going to have a mistake in your etched product, and that's something you don't want.
Okay.
So it's very important to have good artwork.
Now what if you're used to using vellum paper?
We don't really recommend vellum, although you can use what we call it's a positive FX film, and it looks just like this.
Okay.
All right. And what this is designed for is for a laser printer. All right? But with this particular thing, you have to be careful that the density is what you need in order not to have light coming through for the exposure step.
And this goes through the laser printer.
This goes through the laser printer and only the laser printer.
Very good.
Okay. So you have the 2 different options, but the one that we absolutely recommend is the one we called the AccuArt.
Right.
Okay?
So we've got our artwork. Now what's the next step in the process?
Okay. Let me describe the film a little bit to you.
Okay.
Again, we're working with a Rapidmask high-tech film. And the high-tech film has a shiny carrier side, which you can see here.
Right.
And then there's a layer of photopolymer after that. On the other side, we have a slip sheet that goes against the polymer and protects it.
And how can you tell which is the slip sheet?
Okay. The best thing to do, because the sides are very similar here, is that we actually take our fingernail and just rub on the corner here. You can feel how hard this side is.
Right.
And if we flip it over and then put your fingernail on there again, you feel how much softer it is.
Yep.
That's the slip sheet side.
Soft side is slip sheet side.
Correct. Now, This is a UV-sensitive product, all right, which means simply that it is responding to UV light.
Yeah, and I've heard a rumor that you can only work on rapid mask film in the dark. Isn't that true?
No, it is not true at all. No, it is not true. There's no difference between this photopolymer and any other photopolymers. Photopolymers are generally sensitive to some form of white light because there is a UV component. But the fact is, this particular product is no more or less sensitive than any other product. But there is a difference. This film you don't wash out, and therefore it remains photosensitive through the blasting. And it's very important then that during the course of time you don't expose this to a lot of white light.
Right. So if you're working on it, and let's say the phone rings, you have to leave the room, what do?
You just cover it, or put it in a drawer or whatever, but you basically cover the film so it's not exposed to light.
Okay.
But you have every bit of 2 to 4 working hours time in a regular white light environment before you'd have to worry about any problem with the film performance.
Okay. So, Vince, you've explained the artwork.
Right.
Told us about the film.
Yep.
I'm guessing we're ready to expose the film.
That's exactly right.
Okay.
And that's really very easy as well. So at this point, we would take our artwork. We bring the slip sheet side against the printed side of the artwork. This is the side that was printed on when it came out of your computer.
Okay.
All right. Bring those two in very close contact. And it's very important that the contact be maintained closely between the artwork and the film. So we're going to take our exposure unit. And the way you have to orient this, because the light comes through the cylinder, you want to make sure it goes through the artwork first and then to the film. So we're going to turn this over, make sure that we have it lined up exactly the way we want it.
Right.
We're going to turn it over, and then we're going to put it in here, and then roll this around so that we maintain good contact, and that's what this blanket does. It keeps good contact between the artwork and the film.
Okay.
Very important.
So now, in the exposure unit, how long are we going to expose the film for?
We're going to set this one, this particular product, for about 2 minutes.
Okay.
Okay. And so we'll just dial here on the indicator. 2 minutes.
And what's going to happen during these 2 minutes?
2 things are happening in here. Actually, the film is changing color. It's going from that green color that we started out with to a blue color, which you see here. And it's also getting brittle in those areas. And that's very important that the film gets brittle because that's how it works. When we go from here, we're going to go right onto a piece of glass and into the machine to blast it. And where the film has turned brittle, the abrasive hits it, shatters it, and the etching begins immediately.
So brittle equals good.
Brittle equals very good.
Okay.
That's correct. And in fact, that's why we need to have enough energy for 2 minutes to get into the film to make it brittle.
And how can you tell if it's brittle?
Okay. The one thing that's neat about this film is it actually tells you, you can set up your exposure unit, and the film will tell you when it's had enough exposure. And the way you do that is you take a little strip of film like this, and you would put it into the light source, and you try some various time settings on your light unit. Take this out, and you bend it back on itself until it snaps.
Snap, yes.
Okay? And that's very important because you need it to snap in order for it to work in a sandblaster. That's how this film works. When it gets brittle, that becomes the area that the abrasive will hit and shatter and start etching the glass.
So you want to make sure you don't underexpose this film.
That's correct. The very important thing is to make sure you get enough energy in it so it gets brittle. Okay? On the other end, you do have a lot of exposure latitude on the top end. You know, you could overexpose this material and it's not going to hurt it as long as you have good artwork.
All right.
And it's good and dense.
So it sounds like the exposure is done, so I'm guessing we're going to step 2, application. Is that right?
That's correct.
All right. So talk us through that.
Okay, sure. First, let's show you the results of the expose step that we just went through.
All right. Removing it from the exposure unit.
Right. And as you can see, we have